So, for this question, we're given the parametric equation of the curve, x equals 2t squared plus 3, y is equal to t squared minus 4t plus 5, and for part A we want to find the gradient where t is equal to 3. So if we see the word gradient, we should be thinking straight away we've got ourselves a curve, so we need to get an expression or a value for dy by dx. However, we're given the curve in terms of parametric equations, so to get to dy by dx, we're going to need to differentiate both of these, in this case with respect to t, in order to use the chain rule, such that dy by dx is equal to dy by dt times dt by dx. So let's take our first expression then, x equals 2t squared plus 3, and let's differentiate this with respect to t. 2t squared becomes 4t, the 3 differentiates to 0, and y equals t squared minus 4t plus 5. When we differentiate that with respect to t, the t squared becomes 2t, minus 4t becomes minus 4, and the 5 goes to 0. So putting that together then, dy by dx in our numerator, 2t minus 4 divided by our dx by dt, which is 4t. So that would be our expression for dy by dx. However, we are given a value. We are given that t is equal to 3. So where t is equal to 3, that implies that dy by dx is equal to, if we substitute in, 2 times 3 minus 4 over 4 times 3. 2 times 3 is 6, minus 4 is 2, over 4 times 3, which is 12, and 2 over 12 simplifies to 1 over 6. So therefore, our gradient, where t is equal to 3, is 1 over 6. So that's our answer to part A. But we do have a part B for this question, which says to find the coordinates of the stationary point on the curve. Now, there's a couple of key parts to this. Now, obviously, our key phrase is stationary point, and you should remember that if you are looking at the stationary point, that means that your differential, dy by dx, is equal to 0. Now, another key part is actually connected to this phrase because they should word it correctly in the question. If it says stationary point, how many points are you looking for? Well, 1. If it says stationary points, then you will be looking for more than 1. So if it says stationary points and you only find 1, well then you've obviously made a mistake somewhere. If it says stationary point and you find multiple, it means that you've obviously made a mistake somewhere. So it can be an extra clue in the question. So dy by dx is equal to 0. Well, fortunately, we have an expression for dy by dx, because remember, we're not specifically looking at t equals 3 anymore. We're just looking for the general dy by dx. So therefore, 2t minus 4 over 4t is equal to 0. So at this point I can say that 2t minus 4 is equal to 0 because the 1 over 4t equals 0 has no real solutions. And rearrange that a little bit then, 4 divided by 2, t is equal to 2. So we have ourselves a value for t, which is great, but we are after the coordinates, not the value for t, so we need to get values for x and for y. Well, we have a t value, we have some expressions for x and y, so all we have to do is substitute in. When t is equal to 2, that implies that x is equal to 2 times 2 squared plus 3. 2 squared is 4, times it by 2 is 8, plus 3 is 11. T is equal to 2. That implies that y is 2 squared minus 4 times 2 plus 5. 2 squared is 4. Minus 4 times 2 minus 8. 4 minus 8 is minus 4, plus 5 is 1. So therefore our coordinates of the stationary points is 11,1. Do not forget, if it specifically asks for coordinates as well, you must display your final answer as a set of coordinates. Do not just leave them as x and y values. Okay? And that brings us to the end of this question.